Hi everyone, welcome back to my channel. Thanks to everyone for adding your questions and comments. It's been kind of hard for me because I've been on holidays and back and forth and trying to get things done plus work. So I figured what I'm going to do is I'm going to do this video to kind of answer a lot of the questions people are asking me. Okay, now everybody's one of the people on YouTube is actually asking me about amperage output. Okay, this, and it seems like from what he's writing me, he doesn't get what this is. This is a battery charger, okay? It is not a high amperage, high power output device. It's not. It's a battery charging unit, okay? So the maximum milliamps that's coming out of this thing is about 200 milliamps, okay? It's taken about zero point 0.2 to zero point 0.3 amps to actually run the system. So right now, this system is running at about 83% efficiency. It's not over Unity yet because you have to get this thing within resonance. And as soon as you achieve resonance, then you can exceed the power that's going out that then you're actually putting in. So, but for now, this is how it runs. Somebody was asking me about the rotor. Okay? The rotor is designed by me. I did everything in AutoCAD Fusion. There's 6 N52 neodymium magnets all the way around, and there's 2 magnets per hole. So it's a total of 12 magnets, but it's only 6 of them going around equally spaced. That's for the router. Now the coil, somebody's asking me about the coil. I use 32 gauge wire, 3D printed spool with a 1/2 inch bolt going through it as the core, and 450 turns of 32 gauge wire. That's the coil. The other questions I was having was power input is 12 volts DC. 12 volts DC, and it's drawing about 0.3 amps. So it's drawing very, very low power. So if you have a hookup to a car battery, it's going to run for a long time. Excuse me. My timing is a 3D printer proximity sensor. That's what I'm using for the timing. I'm not using a reed switch. I'm finding I get a quicker response time with the proximity sensor, and it's easier to dial in. The switching device, I'm kind of on the fence right now between this one here. It's a solid state relay. It will run the motor faster, a little bit more efficient, but when it comes to actually pumping out amperage, like this, I've been able to get this up to 200 milliamps, but using this switch has been very, very difficult. I'm finding my best results are with an automotive relay switch. This is where I'm getting an actual spark in there. And if you get this thing within resonance, what happens is you start achieving what's called almost like a 0 point vacuum, where the spark actually starts getting cold, where versus getting hot. If it's getting hot, that means you're not achieving resonance with the motor. So I use a thermometer while I'm tuning it, and I can actually see the spark and actually see the temperature variation, what happens after it starts running. If the spark starts cooling off, you know you're achieving resonance, and you'll get maximum power output as well as the least amount of power draws. So that's when you start achieving that over unity effect. Right now, this thing's running at about 83%. I use a filter capacitor on the power that's coming out. Now, somebody was asking, do I need a voltage regulator for the spikes? No, because I'm using 12 volts, and the way I'm switching it and the amount of turns that I have on it and the RPM level, it keeps me at about 12 to 13 volts DC output. All right, at about approximately 200 milliamps. Okay, so from there, the power comes out, goes to the switch device, comes back, goes through my bridge rectifier, which changes the AC pulse into a DC, and then from there it exits, the unit comes out, and this goes to your battery or whatever you're going to do. So hopefully this will help some of you out with your questions. I'm trying to keep this video as short as possible. And don't forget to subscribe to my channel if you haven't. Don't forget, give me a thumbs up if you like the video. And I appreciate all your questions. All right, we'll see you soon.